Hello guys, welcome to my channel Toppers classes Ara. Today we will learn how to represent root 3 on number line. Similarly, we will learn how to represent root 5 on number line, root 7 on number line. In last video, I explained how to represent root 2 on number line. Okay, so this is the continued part of that. So we have to represent root 3 on number line. Okay, so how we will get root 3? We can get root 3 as root 2 square plus 1 square. In last video I have explained, suppose we take this as 1 unit and this as root 2 unit, then this line will be equal to root 3. How? By Pythagoras theorem. This is the 90 degree, this one is perpendicular, this root 2 is base. So what we get as hypotenuse? This is hypotenuse. What is hypotenuse? It will be root 3. Hypotenuse is perpendicular square plus base square. So perpendicular is 1 and base is root 2. So we will get h as root 3. So by applying this logic we can represent root 3 on number line. So just draw a number line here. Suppose this is the number line, and here it is 0, here it is 1, here it is 2, here it is 3. Now we have to represent root 3. So first we will represent root 2, then we will represent root 3. So this is 1 unit, 0 to 1, this is 1 unit, this whole part is 1 unit. So suppose this point is A and this 1 unit point is named B. Okay, so at P draw a perpendicular of 1 unit. So this is 1 unit as we draw in last video root 2. Okay, so this join this one A to this point. Suppose this point is C, so this AC represents root 2. I explained this thing in last videos. You can go on my channel and you can see. I will give the link of that video in this video. Okay, so this is root 2. Now we have to make root 2 as base and we have to take 1 unit perpendicular. So take here 1 unit perpendicular. So this is 1 unit. Suppose this point is D. So what is AD? AD will represent hypotenuse. It will be equal to root 3. So the length of AD is root 3. So now we have to put compass one end at A here and pencil in at D, and we have to draw a line like this. Yes, now this point will represent root 3. Okay, so I am explaining it one more, then it will be very clear. So on next page, suppose this is a number line, this is 0, this is 1, this is 2, this is 3. So first of all take, suppose this point is A, this point is B. Draw a perpendicular at B of 1 unit. Suppose this is 1 unit. Okay, now join AB, it will give root 2 according to Pythagoras. Now take, suppose this point is C, take 1 unit perpendicular at C. This is perpendicular 1 unit. Okay, suppose this point is D and this is 1 unit perpendicular. Just join AD, it will give root 3. Okay, now just put compass one end, that is sharp end, at point A and pencil end at point D and just cut an arc like this on number line. So where this arc will cut the number line, that point is root 3. So this point is root 3. Okay, this is very simple. In exam you have to write the steps. So step is very simple. You can write like this. Step 1, and draw a number line. Draw a number line. In exam you have to write the step, otherwise examiner will deduct your mark. Draw a number line. And step 2, mark 0 as A, 0 as A and 1 as B. Okay. Now step 3 is take a perpendicular of 1 unit at point B. Take BC equal to 1 unit which is perpendicular on a number line. Now step 4, join AC which is equal to root 2. AC will be root 2, which will be root 2. Now at point C, take CD equal to 1 unit which is perpendicular to OC. Means CD is that is CD perpendicular to AC. Sorry, yes, you can take AC. We have taken 0 as A. Okay, so I confused here. This is not OC, that is 0. Okay, so we can take it as AC. Just 1 second. This is AC. Means CD is perpendicular to AC. That is 0. That is not O. Okay, it is 0. Now next step is join AD. Join AD which is root 3 and cut an arc of length AD on number line. Suppose this point is E, number line. The point E represent root 3. E represent root 3. These are the steps. You can write it. Okay. Now we have done root 2, root 3. Now next question generally asked root 5. Represent root 5 on number line. It is in NCERT exercise 1.2 question number 3. Represent root 5 on number line. Okay. So how we will represent root 5? There are 3 methods. So generally we should know only one method because that is the famous method. So how we can write root 2? We can write root 2 as 2a square plus 1 square, because 2a square is 4 and 1 square is 1. 4 plus 1 it is 5. Okay. So make the base of triangle 2 and take 1 unit perpendicular. So this will represent root 5. Okay. So we will apply this logic. So take here a number line. take this as 0, this point as 1, this point as 2, this point as 3, this point as 4. Now we have to take 2 unit as base, so take from here to here as base. So suppose this point is A and this B, 2 point is B. Now take 1 unit perpendicular at B, means at 2. So take 1 unit perpendicular, suppose this is perpendicular 1 unit. Now join AC, suppose this point is C, join AC. So this AC will be equal to root 5. Now just as earlier we do, put on compass sharp end at A and pencil end at C and cut an arc just on number line. Okay, cut an arc on number line. So this point will represent root 5. Okay, so steps is same, you can write it in your own word. There is no any special method, you can write whatever you have done. Okay, so step is nothing, you can write it in your own word. Now you have learned root 2, root 3, root 5. Okay, now coming to exercise 1.2, we will see some questions, how we will solve that question. Okay, so I am bringing the question, just 1 second. Exercise 1.2, just 1 second. Yes, this is the exercise 1.2. The first question is, state whether the following statements are true or false. Justify your answers. In this question it is saying we have to check whether the given statements are true or false, and we have to also justify, means we have to give the reason. The first question is, every irrational number is a real number. Every irrational number is a real number. So whether it is true or false, we have to check it. So I have discussed earlier, real number has two parts, rational and irrational. Okay, so all the irrational number will be real number, because rational number is the son of real number, and also rational number is the son of real number. Son means putra, beta. So we can say all the irrational numbers are real number and all the rational numbers are also real numbers. So this statement is true. First one is true, because all the irrational numbers are real number. Okay, now coming to point 2, this was the first. Now coming to question number 2, every point on the number line is of the form root m, where m is a natural number. Okay, where m is a natural number, remember this thing, it is given m is a natural number. So we will see all the point. This statement is false, I will show how it is false. Suppose this is the number line, this is -2, this is -1, this is 0, this is 1, this is 2, this is 3. Now it is saying every point on the number line is of the form root m, where m is a natural number. So see here, this is 3, so we can write it as 9. Square root of 9 is 3. So it is of the form root m, where m is natural number. Here natural number is 9. Okay, natural number is 9. Now coming to point 2, we can write it as root 4. So here natural number is m is 4. So we can represent root 2 and 3 as root m. Root m I have shown, this is root m. Now coming to point 1, we can write it also as root 1. Here m is 1. Now coming to point 0, we can also write at root 0. Root 0 means 0. Here m is 0. But it is saying m is a natural number. So 0 is not a natural number. So here it fails. M is 0. 0 is not a natural number. It is a whole number. Coming to point -1, we cannot write -1 as root m. There is no any natural number whose square root is -1. Okay, there is no any natural number whose square root is -1. Also here -2. So there is no any natural number whose square root is -2. So in all the negative cases, in all the negative integers and including 0, this statement fails. Root m fails because here m is given natural number. Okay, so it is not applied for all the negative integers including 0. Okay, for positive integer it is true, but for negative integers including 0 it is not true. So this statement is false. Okay, now next question, question number 3. Every real number is an irrational number. What is third part? Every real number is an irrational number. So I already explained here, real number has two sounds, rational and irrational. So it is saying every real number is an irrational number, means any real number is an irrational number? No. For example, if 3 is a real number, 3 is a real number, so we cannot say 3 is an irrational number. Okay, 5 is a real number, we cannot say 5 is irrational. Okay, so every real number cannot be irrational. Okay, real number have two sounds, rational and irrational. So every real number can be rational or irrational. Okay, any real number can be rational or irrational. Okay, but every real number cannot be only irrational. Okay, I have given example, root 5 is a real number but it is not an irrational. 3 is a real number but it is not an irrational. Okay, so this statement is also false. Now question number 1 completed. Now question number 2. Just 1 second, I am bringing the question number 2. Just 1 second. Yes, this is the question number 2. Question number 2 is saying, are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Means it is saying, are the square roots of all positive integers irrational? Means it is saying a square root of all positive integers are irrational. If not, give an example. So definitely it is incorrect. Suppose 9 is a positive integer but a square root of 9 is 3, which is not irrational, it is a rational number. Okay, so here it fails. It is saying question, just first of all please understand the question. What is saying? All the square root of all positive integers irrational. So I have taken one positive integer 9, the square root of 9 is 3, which is rational, but it in question it is asking irrational, so it is not irrational. So here it fails. There are many more examples. Take 4. 4 is also positive integer. The square root of 4 is 2. It is also a rational number. Now you can take many more examples. 16, square root is 4. It is also rational. Okay. So it is asking only one example. I have given 3 examples. You can take root 25. There are many more examples. Okay. It is also a rational. Okay. Give an example of the square root of a number that is a rational number. So there are many examples. This you can take any one. Okay. So this statement is incorrect. I have explained. Just you have to give the example. Okay. Now this is completed. And question number 3. Question number 3 is represent root 5 on number line. So I have explained already how to represent root 5 on number line. Okay. Now there are only 4 questions. I have explained all the 3 questions. Just there is only one question left, that is question number 4. Okay. So question number 4 I am bringing. It is very important and it is very conceptual question. Many questions will be solved by using this question. Okay, just 1 second, I am bringing the fourth question. Yes, it is very important question. It is actually an activity question. It is written clearly here. It is classroom activity. Okay, it is saying constructing the square root spiral. Take a large sheet of paper and construct the square root spiral in the following fashion. Just it is shown here on the right side. It is shown here like this. We have to draw. Start with a point O and draw a line segment OP1. OP1 is this. Okay, of unit length. OP1 is of unit length, means length is 1 unit. Draw a line segment P1 P2. It is P1 P2. This is also of 1 unit. It is perpendicular on OP1. Now draw a line segment P2 P3. This is P2 P3 of 1 unit. Okay, like this we have to continue and we have to represent. Okay, in this manner you will have created the points P2 P3 and join them to create a beautiful spiral depicting root 2 root 3 root 4. Okay, so this question is looking confusing, but when I will solve it will be very clear. Okay, so just see here. I am moving to next page, so we need more space. Just 1 second. Yes, now we have to construct a square root spiral. A square root spiral. What is this? Just 1 second. See here, suppose this is the number line. Okay, so a square root spiral means we have to represent root 1, root 2, root 3, root 4, root 5, root 6, root 7, etc. We can represent all things. Okay, so take this as 0, this as 1, this as 2, this as 3. Okay, so a square root 1. A square root 1 means this 1 unit. This is square root 1 from here to here, 0 to 1. So no need to represent it. Now root 2, as earlier I have discussed how to represent root 2 on number line. So draw a perpendicular of 1 unit here and join this to this. This represents root 2 because this is 1 unit and this is 1 unit. So this represents root 2. Suppose this is point A, this is B. Now again take 1 unit perpendicular here. Okay, 1 unit perpendicular here from A. So this represents root 3. How? You have to draw it by a scale. Okay, it will be a straight line. How it is representing root 2? As I have already discussed, root 3 we can represent at root 2 square plus 1 square. Root 2 square is 2 and 1 square is 1, so it is root 3. Similarly, we can represent taking 1 unit here. The next number will be root 4. How? We can represent root 4 as root 3 square plus 1 square. So root 3 square is 3 and 1 square is 1. 3 plus 1 is 4, root 4. Okay. Similarly, we can take 1 unit perpendicular here and we can join from O to that point. You have to join it by a scale. Okay, then it will look straight. So this line represents root 5. Similarly, we can represent here root 6 by taking 1 unit. This is representing root 6. Similarly, you can represent by taking 1 unit. This will be root 7. Like this you have to move. Okay, you have to go on. Then this will called a square root spiral. Okay, so any number root 2, root 3, root 4, root 5, root 6, root 7, root 10, root 11, root 13, any number you can draw like this. Okay, now we have learned root 2, root 3, root 5. Now many times it asks root 17. Represent root 17 on number line. Okay. So I will represent root 17. So we can write root 17 as 4 square plus 1 square. Means you have to take 4 as base and 1 is this. So this will represent root 17. 4 square is 16 and 1 square is 1. So it will be root 17. So just take this as 0, 1, 2, 3, 4, okay, and 5. Okay. So now take 1 unit at 4, because we have to make 4 as base. So 1 unit, suppose this is 1 unit, you have to make it by scale. Okay. Now join this to this point. Okay. So this will represent root 17. Okay. Just 1 second. We have to erase the line, this extra line. So this line is representing, this hypotenuse is representing root 17. So you can represent any number by using a square root spiral or by using suitable methods. Okay, I have explained everything. This is a very important question, many students confused in this. Okay, when I was studying, then at that time I was not knowing clearly this thing. Okay, because at that time my teacher didn't explain it clearly by using this triangle. I am explaining this triangle because root 17 came here by using Pythagoras. Okay, but my teacher didn't told this thing, so I explained you very clearly by using Pythagoras. Okay, they just tell this thing, so we remember this thing, like we are remembering like Hindi or any other subjects. So this is a very important concept. You don't have to remember anything in this. This is mathematics, so just you have to understand everything. Okay, so this exercise 1.2 has been finished. Now we will start next topic tomorrow. Please like, share and subscribe my channel. Thank you.